I'm audible to myself also, and that's a bit funny. So, we started the morning with a very interesting thing. That was Saraswati Vandana. So I just take the last verse from it. Samam Patu Saraswati Bhagavati Nishesh Jadya Pahar. So what we are talking about in that is we are praying to the goddess Saraswati to get us out of our inertia. I refer to it as inertia because I'm a motor person, but basically it means get us out of our lethargy. So that's one of the topics that I will be addressing. The second topic was addressed by Ladhaji of trust. So that is the second thing that I will be talking about the lack of trust, unfortunately, not trust. The president addressed a very interesting theme, and that was challenging conventional wisdom. My entire presentation will be based on exactly that, challenging the conventional wisdom. And I will start with the sad reality. I'll draw a parallel for you to get an idea of where I am coming from and where I am going to. Recently, there was a huge show of strength about the Indian culture when Ram Lalla was installed in Ayodhya. Let me take you to the days of Ramayana or the stories that are talked about. After the war was won, after Ravana was vanquished by Ram, Ramji, Lakshmanji, Sita, and Hanumanji, and a few people came all the way back to Ayodhya by means of Pushpak Viman. A very good thing that talks about, a very good story that talks about the glorious past that we might have had. But the sad reality is, go to any airport today, you either see a Boeing or an Airbus or an Embraer. Why do you not see a single Indian passenger aircraft? And when I talk about this, I'm just drawing the parallel to this. The world's first energy efficient motor standard was IS 12615 way back in 1989. 19 years after that, the first international standard, IEC 60034-30 was established. 19 years after that. The sad part is, the same way, there's Boeing and Airbus and all that thing, the sad part is, though the international standard, the International Electrotechnical Standard came in 19 years afterwards, Europe has the best possible MEPS requirements, minimum efficiency performance standards of IE4, and we are still struggling at IE2. The population of high and premium efficiency motors in the country today is less than 5%. And I will address a few questions that if you can take with you, will perhaps help us change this situation. So that's what my topic is about, change the way you think. And the question obviously is why? Why should one change the way you think? So what can you see? Can I have some answers? A garbage bin which is floating. Thank you. So the garbage bin is not floating, unfortunately. It is just that there is a shadow, there's a wet spot in front of it on the pavement, and that's what is giving it its appearance. So what you see is generally governed by your imagination, and what you see is also governed by your thought processes or what your beliefs are. So let me give you a demo of that. Can you read this? Do you believe what you see? Very great. This one? Do you trust your brain? Are you? Sure. Very good. Have you ever jumped to conclusions? Very good. So, you see only what you believe. And now, dear friends, you see only what you believe. And therefore, the need to change your thought process, the need to change the way you think, because whatever you had been reading was all humbug. I do not know what you were reading. That was never mentioned over there. So, with that message conveyed, sometimes your beliefs prevent you from seeing the truth. The experience of your previous slide is the largest proof for the same. These are the 7 thoughts which you need to change immediately. Efficiency difference is the deciding factor. The fine print may be taken lightly. CE marking applies only to the European Union or European Economic Area. I have many pumps. Let me get new energy efficient motors for the same. We have appointed a reputed consultant for the project. Think out of the box is just another trainer's jargon. Many a times, think out of the box, बोला तो यही हमें लगता है कि okay, that's generally the way trainers speak. And finally, higher motor efficiency is the best way towards energy conservation. These 7 thoughts, I request you to change immediately. I'll take you through all the 7 of them in my slideshow. I'll not dwell on irrelevant slides for long. Unfortunately, right now I cannot hide certain slides, but I'll go through them. So think not about the efficiency difference. Think about the energy saved. And why do I bring you to that? Is if you look at IS 12615-2018, I'm just taking an example of a 75 kilowatt 4-pole motor. Why I like this rating? Because the efficiency of this from I2 to I3, I3 to I4 increases by just 1 percentage point. 94 का 95 होता है, 95 का 96 होता है. And then people say, बस एक ही टका efficiency improvement हो रहा है, why should we go for a higher efficiency motor? And this is where the thought process needs to change. So if you look at the efficiency related power input, which is there for I2 motors and then I3 motors, the difference between I2 and I3 is only 0.84 kilowatt. And by the same logic, difference between I3 and I4, sorry, I2 and I4 is only 1.66 kilowatt. And this is what we concentrate on. Efficiency difference is not significant. Why should we invest into it? Point is, 0.84 kilowatt savings accrued over 360 days a year, 24 hours a day, amounts to 7.3 megawatt hours of savings. Single 75 kilowatt IE3 motor. And this is if IE3 was used instead of IE2. If IE4 were to be used instead of IE2, that is 14.4 megawatt hours. If you feel that 14.4 megawatt hours is a negligible amount, you can drop changing the first thought. But if you feel that no, that is a significant amount, that's the first thought process that you need to change. Do not look at efficiencies, look at the energy savings. Coming to the second point, ignore the fine print at your own peril. Again, I'll take you to the Indian standard, but before that, a word of caution. Read the standards carefully. These are meant for the benefit of the user. This slide we saw, let me just change the view. Instead of it, now let us look at the efficiency value of an I2 motor of 75 kilowatt and a 90 kilowatt motor. So it is 94% and 94.2%. Now, this is the way efficiency versus load curve for an induction motor looks. And if you look at it on a graph, you can make out that the maximum efficiency point is between 80 to 90% of the loading. This is because generally the motors operate at these kind of loadings. The corollary from the curve itself says that if you overload the motor, your efficiency will further drop. So what? So what? On the page 1 of the Indian standard, there is a footnote 5. Footnote number 5. Now, naturally, the moment it's a footnote, it is ignored. I'm sure you cannot read the footnote at the rear end as yet. I'll expand it, blow it up a bit more. Do not worry, just get the message. Ignoring the fine print is what causes the greatest harm. And now I'll take you to this harm that it causes. So what is this footnote? Now I'm sure you can read it. The footnote says service factor greater than 1 is intended for a short time that is less than 1 hour only. Why am I bringing this to the notice? Every industry has at least a few compressors operating, and the entire compressor industry in India operates with service factor motors. So, if you go to the plant and check the motors log, especially for compressor motor, you will find that these motors operate at service factor loading, not for less than 1 hour, but significant amount of time during the day. So what happens? A 75 kilowatt motor operating at the load of 90 kilowatt, that is service factor 1.2, the efficiency drops from 94% to 93.76%. That results in a power input of 95.99 kilowatt. Instead, if you were to instill a properly sized 90 kilowatt motor, its inherent efficiency is 94.2, and you get a savings of 0.45 kilowatt, which by the similar formula translates to 3.9 megawatt hours. Worse, with the service factor motor, because the nameplate of the service factor motor reads 75 kilowatt, effectively you are sinning, if I may say so, when you declare a maximum demand based on the 75 kilowatt of the nameplate output. Your actual demand is 90 kilowatt. So that's a different discussion. We are not going to have it here. Just take home this idea that if you were to use a proper 90 kilowatt motor instead of a 75 kilowatt one, you save 3.9 megawatt hours. I'm sure 3.9 megawatt hours is attractive. Now, coming to the third part, act local, however, think global. And a lot of things were said in the previous session about how different nations have taken steps and leaps further in energy efficiency. So on that, I will be talking about addressing the issue of, sorry, this is not supposed to be Shakespeare. Yeah, that's correct. To CE or not to CE. So CE marking is mandatory only in the European Union or European Economic Area. Agreed. No second thoughts on that front. However, it can benefit you in a very big way. How? No, this slide is not out of place. The most favorite destination for any Indian vacationer is Europe, just because it is spick and span and a very nice greenery and a nice, environment over there. But the reason for this nice environment is what we call as their CE regulation. So this is the CE regulation, which talks about, let us look at from the immediate past. Any motor supplied after 1st of July 2023, which falls within the category 75 to 200 kilowatt in 2-pole, 4-pole, or 6-pole, if you want to send it to Europe, it has to be at least IE4. We are still stuck at IE2. And let me be very brutal about this. There are ways and means that are devised every time. I'm not saying in the paper industry, I'm not saying any specific industry, but at various places, methods and means are devised to find out, can we still get a non-IE motor because it is cheaper? IE2 की बात तो छोड़ो, ये भी thought process चलते रहता है. So, the advantage of this particular CE regulation, before that, let me tell you one more thing. The European Union has the most stringent MEPS. However, this CE regulation does not prevent European manufacturers from manufacturing IE1 and IE2 efficiency class motors for export to other countries. उनके वहाँ minimum IE4 है, but they are allowing IE1 to be manufactured for export to so-called third world countries. And thankful to Mr. Modi, now we do not categorize a third world country. However, CE is not just a mark on the nameplate. To mark a motor CE, one has to begin right at the design stage, and CE mark is a very serious commitment of efficiency. So I will explain in just 3 slides how is it so. So official journal of the European Union, just to bring about a credibility to what I'm saying by showing you an authentic document. Whatever is indicated here in the highlighted text, I'm sure it can be read. It is effectively nothing but the tolerances that are allowed as per the standard shall not be used by the manufacturer, importer, or authorized representative to declare values in the catalog. or on the nameplate, or declaring conformance to the CE regulation or any energy efficient EU regulation qualifying criteria, or declaring or communicating better performance figures. So I'll skip the next thing. Now coming to what it means is a 75 kilowatt IE4 motor, as I said, needs to be 96% efficient to be called IE4. Considering the tolerance, 75 kilowatt is within the 15% bracket, so 96% can reduce to 95.4%, considering the tolerance. So if your tested efficiency of the entire sample of the same design, which you are releasing into the market, categorizes between 95.4 less than equal to efficiency less than, I'm not saying less than equal to now, less than 96, can the motor be called IE4? Yes. Can it be marked CE? No. And that's why when you insist for a CE marked motor, you just do not get an IE4 motor, but you get a motor which has a design which is designed for an efficiency to supersede or surpass whatever is the qualifying criteria requirement. So these are motors marked with CE, and these are motors marked without CE. This is just to give you an idea. Motors which are marked CE are designed for nominal efficiency, meaning tolerance is not considered. The declared efficiency must have been tested. ऐसा नहीं कि calculated था software से वो declare कर दिया. No, it has to be tested. And from any given random sample, a lesser percentage of motors will need the full permissible tolerance to clear the CE marking requirement. On the other hand, I do not wish to dwell on the negatives. The slides are available with Mr. Goel. He'll be loaded onto the APPTA website. You can go through that. So just to close this topic, why CE? Because CE means true efficiency. Coming back to the point where we started, you may be told CE is not mandatory in India. Agreed. It is not mandatory in India. It is in your interest that you insist for a CE marked motor. Now, coming to a very interesting topic. Think before you leap. This is something as of a very old adage. And what happens if we forget it? So think before you replace existing motors blindly, especially for centrifugal pumps and fans. Now, why am I talking about these particular equipments? Is in the industry, 66% of the motor-driven applications comprise either of fans, blowers, pumps, or compressors. And because these are the major chunk of population, the first experiment that is performed of replacing an existing motor with a high efficiency one happens on these kind of equipment. The international standard TS 60034-31 makes an interesting observation. What does it say? In general, motors with higher efficiency have a higher operating speed, and it also says that on average, the slip reduces by 20 to 30% when you go from I2 to I3, I3 to I4. So what does this 20 to 30% reduction in slip mean? So if we take a 15 kilowatt machine for a 2-pole, if you are running an I3 motor instead of I2, it would run 28 RPM faster. And from I3 to I4, it will run around 19 RPM faster. This is for a 2-pole machine. The figures are slightly lower for 4-pole machine, obviously because 4-pole synchronous speeds are 1500. That doesn't matter. What I want to bring your attention to is the statement in the international standard. If an existing motor is replaced with a more efficient one, the higher speed may put higher demand on the motor. This is something that you need not worry about if you are setting up a new plant. But if your existing plant, you are trying to carry out a replacement, beware of it. Because this rebound effect can bite you like nobody's business. Everybody knows a centrifugal pump has an affinity law. So flow is proportional to speed, torque is proportional to square of the speed, and power by simple mechanical engineering equations is proportional to cube of the speed. मुझे ये सवाल पूछा गया था टाटा मोटर्स जमशेदपुर में, भाई साहब आप बड़ी बड़ी बातें तो कर गए, एक 10-15 आरपीएम, 5-10 आरपीएम, 6-7 आरपीएम, 1500 की कंपैरिजन में कहाँ चला जाएगा पता भी नहीं चलेगा. This was exactly a question raised by Tata Motors Jamshedpur, and therefore I take an example of bill of quantity of Tata Motors Jamshedpur. So if all their IE2 motors are replaced by IE3 motors, assuming that there is no speed change from IE2 to IE3, the potential of their paint booth, where they paint the trucks, energy saving potential is 460 megawatt hours. Not a small idea. However, ये चंद आरपीएम क्या फर्क पड़ता है? So this slight change in RPM causes this 460 megawatt hours to convert into an increased power consumption of 54 megawatt hours. So replace any existing pump or a fan motor blindly. Your first impression will be मेरी मोटर वाले ने मुझे चूना लगाया. क्यों? मेरा कंजम्पशन बढ़ गया. बढ़ना नहीं चाहिए था. भाई साहब बढ़ना चाहिए था. और इसलिए मैं बता रहा हूं कि क्यों बढ़ेगा. Because a pump follows affinity laws. Then there is a counter argument. हाँ, पर स्पीड बढ़ेगा तो फ्लो भी बढ़ेगा. Agreed. I showed you in the first place. Flow is proportional to speed to the power 1. Power demand is proportional to the speed to the power 3. As long as x is greater than 1, x raised to 3 is significantly greater than x raised to 1. So whatever justification you want to think about it, it is घाटे का सौदा. So blind replacement of I2 and I3 motor with I3 motors will always result in, or may sometimes result in unpleasant surprises. Always is a very big, a very strong statement. So does it mean one should never replace old motors with new higher efficiency ones? We never say that. For pumps, if the application permits, trim the impeller. Trim the impeller to a smaller diameter to account for higher speed, and you will get the calculated savings without any hitch. In case of fans, which are generally driven through a belt and pulley drive, change the pulley ratio. Ensure that the driven machine runs at original speed. You are guaranteed of the calculated savings. हाँ, पर ये तो आप कह रहे हैं. Yes, this is where comes the matter of trust. जब तक मैं हिंदुस्तानी ऑडियंस को एक हिंदुस्तानी नजर आता हूं, ये स्टेटमेंट आप कह रहे हैं जाता है. जब मैं इंटरनेशनल स्टैंडर्ड का बैकअप दिखाता हूं, that time the same statement now becomes more acceptable. A practical solution in this case would be to adjust the impeller diameter of the fan. Says who? Says IEC 60034-31. मैं मेरी मन की बात नहीं कर रहा हूं. And कहने की जरूरत भी नहीं होनी चाहिए. All of you us are engineers over here, and basic rule of pumps always says power is proportional to cube of the speed. Great. With that, we have covered the first 4 part of it. गोयल साहब, कितना टाइम बचा है मेरे पास? 30 minutes. I think I will be able to do justice to the rest 3 topics also. So, energy conservation is your responsibility. What do I mean by that? You could be buying energy inefficient motors without your knowledge. And why does this happen? Because we do not put our brains to use. And this is where the trust that was talked about, unfortunately, comes back to bite us, because we trust the consultant a bit too much. So I'll show you one interesting vacancy notification. It's a matter of some fun element over here. So I know this is a bit blurred image. Let me just blow it up. A cement manufacturer having a pan-India presence requires for their corporate office in Mumbai urgently a photocopy machine operator. Just look at the specification. Fresher or maximum 1 year experience, qualification B.Tech with distinction in computer science. अब सच बताइए, हंसी आई? फोटोकॉपी मशीन ऑपरेटर के लिए B.Tech किसको चाहिए? क्यों चाहिए? नहीं चाहिए. Nobody hires a photocopy operator by this specification. I also know that this ad was fabricated by me. The sad part is, you don't hire a person like this, but when it comes to purchasing a motor, it's an entirely different case. That's what I will now go further. So shocking facts and figures, 300 million electric motors operate around the world. I'm not getting into this part of it. बाकी का छोड़ दो, इतना आज के लिए इतना डिसीजन इतना डिटेल जरूरी नहीं है. Out of those 300 million electric motors that operate around the world, 95% of them are oversized. The sad part is in the Indian industry, this oversizing amounts to 97%. So experience shows that the most significant cause of inefficient motor operation is oversizing. And why does oversizing occur is what my next case study is. So in every Indian family, we have a picture of a hum do, hamare do, generally taken in a studio in front of some Swiss Alps or some nice background. And every Indian family also has a picture of the children's graduation in the university where, abroad generally, where the child has graduated. Forget it. These two pictures show only the nuclear family. However, when we have a wedding, it's a big fat Indian wedding. Now, what have these three slides to do with our discussion today is a question that I'm going to ask. If money were not the criteria, if loan obtaining was not an issue, considering the fact that you have your ward's wedding in the near future, a sure shot event which is going to occur, and you are going to invite a lot of guests. For them, you need to transport these guests to the venue, from the airport, from the railway station, etc. So would you purchase a four-seater, or would you purchase a bus? And let me tell you, regardless of how many times I have asked this question, the answer is always, sir, we will purchase the car. We will not purchase the bus. क्यों? शादी तो पक्की है, तय है, होने वाली है, अभी तो कोविड रेस्ट्रिक्शंस भी नहीं है, बड़ा फैमिली गैदरिंग भी हो सकता है. नहीं सर, पर वो एक दिन का बस का इस्तेमाल के लिए पूरा पिछले इतने सारे साल बस का खर्चा क्यों उठाए? वेरी वैलिड एंड अ वेरी थॉट अबाउट आंसर. द क्वेश्चन इज, ये पूरा थॉट प्रोसेस मोटर की खरीदी में कहां चला जाता है? So the slides displayed here are based on factual observations. I'm going to show you all these factual observations. The opinions expressed are purely personal. Nowhere has Siemens appeared on any of the slides as yet. So it is, if you feel like मेरी नाम की सुपारी देनी है तो मेरे नाम की देना, Siemens के नाम की नहीं. Any resemblance to reality is purely coincidental. And sorry, it is actually intentional. And what I mean by that? Yeah, I'm winking. Yes, I'm the devil as well as I'm going to be the saint. And I'll explain to you how, in spite of being a devil, I am going to be the saint for you. So the major causes for oversizing are these four generally observed clauses in a consultant specification. Stringent and uncalled for restrictions on starting current. माफ कीजिएगा, आई एम ओपन, मैं सज्ज हूं, जैसे महाभारत वगैरह सीरियल में कहा जाता है, मैं सज्ज हूं अगर कोई मेरी हत्या करना चाहता है तो, फॉर मेकिंग अ स्टेटमेंट दैट द ईस्टर्न इंडिया कंसल्टेंट फ्रैटर्निटी इज स्टिल स्टक एट 6 times starting current. In the west world, northern world, southern world, they have changed. But in eastern India, they still stick to 6 times. I do not know why. Specifying motors for a high voltage variation. Misconceptions about locker to withstand time and thereby resulting clauses in the consultant specs, and our habit of never challenging the ancestors, a point which Mr. President addressed, challenging the existing practices. So these are very, and I know readability is an issue because I have just taken screenshot, deliberately screenshots liya hai ताकि authenticity maintain हो. Every consultant talks about starting current not exceeding 6 times. However, the Indian standard talks about IE3 motor के लिए 7.7 times the rated, IE4 के लिए 8.9 times the rated. The consultant still wants, नहीं मुझे 6 times the rated चाहिए. I'll come to that a bit later. This is for 2-pole, this is for 4-pole. I'll just skip this slide a bit further. The second part, I want a motor suitable for 415 plus 10 minus 15%. क्यों? मेरा प्लांट सर रेणुकूट में है, रेणुकूट इतना गॉड फोर्सेकन जगह पे है कि वहां पे दिन में बेयरली 360 वोल्ट मिलता है। ठीक है, तो 380 वोल्ट का मोटर ले लो। नहीं नहीं सर, रात को 2 घंटे के लिए 460 वोल्ट भी मिलता है। सो instead of buying a motor which is designed for a wider voltage variation, go for a motor which is designed for a nearer voltage as exists most of the time of the day. Because if you look at these curves, the yellow curve is what I will draw your attention to. That's the efficiency curve. That's the only curve which deteriorates either side of the supply variation. Otherwise, power factor improves if your voltage reduces. Starting and breakdown torque improves if the voltage increases. So there are positives and negatives on either or the other side. But efficiency is the only parameter which goes bad regardless of which side you operate. And therefore, it is in your interest to run a motor which operates at near the rated voltage. Or you buy a motor which is rated for a voltage which your system sees most of the day. This is what the Indian standard says. I'm not talking about the temperature rise, I'm talking about the other part. What it says, in motors operated under extreme conditions may not necessarily comply with the standard. मतलब जो भी efficiency वगैरह का जो आपने calculation लिया था, वो सब calculation fail जाने वाला है. And it is what the standard says. But again, coming to the trust issue, do we trust an Indian standard? No. Therefore, let us look at international standard. So IEC 60034-30-1 very clearly, in no uncertain terms, makes an interesting statement. The following motors may not be able to reach higher efficiency class specification, that is IE3 and above. Motors with reduced starting current, motors for special characteristics of great supply such as motors with limited starting current, or motors with wider voltage and frequency tolerances. It sounds very interesting. Plus 10 minus 15 sounds very interesting. क्यों? हम लोग हिंदुस्तानी ठहरे, हमें बड़ा सो बेहतर ये बिलीफ पहले से इंग्रेन कर दिया गया है, लेकिन मोटर के केस में वो उल्टा गिर रहा है आपके लिए. Now, I'm going to ask a question with a definite knowledge that I'm not interested in your answer, because the answer to this question is a bit difficult. If I ask you what is the voltage across A and B with two sources which have the identical internal impedances connected. I know this circuit is going to be difficult to analyze, so let me simplify the circuit. And now I can expect an answer, but let me tell you very frankly, I'm not interested in the answer. I'm not interested in the answer because one thing for sure, whatever this value of X between A and B is never going to be 110 and 80 simultaneously. Do you agree with that? Now, if you agree with that, let me show you a consultant specification. For motors rated 55 kilowatt and above, the locked rotor withstand time under hot condition at 110% voltage shall be at least 5 seconds more than starting time at 80% voltage. ये क्या बेहुदा चीज है? मोटर को ये कैसे पता चलता है कि मुझे लॉक रोटर करंट खींचना है वो 110% वोल्टेज के हिसाब से खींचना है और टॉर्क जनरेट करना है वो 80% के हिसाब से? दोनों वोल्टेजेस साइमल्टेनियसली तो एग्जिस्ट होते नहीं है. बट व्हाट हैपेंस बिकॉज ऑफ दिस क्लॉज? What happens because of this clause? I'm not getting into the details of reading out the problem statement. I'll just tell you what happens because of this clause. If this particular requirement of a consultant has to be met with, for an absorb power of 45 kilowatt, a 55, 75, 90, 110, 132 kilowatt motors are not suitable. The next motor which is suitable for meeting this consultant requirement is a 160 kilowatt motor for an absorb power of 45 kilowatt. All of you are engineers, दिल पे हाथ रख के मुझे कहने की जरूरत नहीं है, खुद सोच लीजिए 160 किलोवाट की मोटर 45 किलोवाट के लोडिंग पे हम किस एफिशिएंसी की बात कर रहे हैं और क्यों कर रहे हैं. एंड इफ आई ब्रिंग दिस टू द नोटिस, नहीं वो कंसल्टेंट स्पेक्स में है, वी हैव टू फॉलो. व्हाई डू वी हैव टू फॉलो? When I'm bringing to your notice, and now I'll give you a slight different out of the box thought process. भाई साहब, आज सुबह को हमने सरस्वती वंदना की. अगर मोटर मैन्युफैक्चरर, एंड आई एम नाउ लुकिंग एट माई सेल्फ एज अ मोटर मैन्युफैक्चरर, अगर मोटर मैन्युफैक्चरर ने रोज सुबह उठ के अगर किसी की पूजा करनी है तो जितने भी कंसल्टेंट्स हैं ना उनके सारे के लोगों की करनी है। लोगोज ऑफ कंसल्टेंट पैटर्न 80। क्यों? जबकि मैं 55 किलोवाट की मोटर बेच सकता था, मैं 160 किलोवाट की मोटर बेच पा रहा हूं। फायदा तो मेरा है जनाब, आपको मैं बता रहा हूं उसमें मेरा नुकसान करवा रहा हूं, तो सोचिए कि आपके फायदे की बात कह रहा हूं। एंड दिस इज व्हाट आई से, चेंज योर थॉट प्रोसेसेस। Nobody has up till now told you this. I'm telling you this, and I'm telling you so bluntly. So, motor rated for 160 kilowatt for a power of only 45 kilowatt. इसको गुजराती में जो लोग भी समझते हैं, हम लोग गुजराती में इसको कहते हैं कोना बापनी दिवाली। This is exactly what it is. Similarly, class F motor, 145 की कैपेसिटी वाला मोटर लेके 120 तक ही चलाना। क्यों? वही बात हुई ना कि मुझे आईआईटी ग्रेजुएट चाहिए फोटोकॉपी मशीन ऑपरेटर के लिए, वहां पे तो हंस पड़े थे, ये क्यों, ये क्लॉज क्यों है स्पेसिफिकेशन में? टू जेनेरिक एंड स्टोन एज स्पेसिफिकेशंस, ये 2010 के साल का स्पेसिफिकेशन है किसी कंसल्टेंट का, लिखा है लेटेस्ट एडिशन। इसका मतलब क्या? जस्टिफिकेशन ऑफ द कंसल्टेंट इज वी मेंशन लेटेस्ट एडिशन बिकॉज वी डोंट वांट एन अर्लियर एडिशन टू बी रिफर्ड टू। Okay, that's their story. My interpretation of this wording, latest edition, means this particular clause number 1.0 of any general consultant specification is never revisited after the specification was made for the first time. And I say this with very great confidence because in 2010, you're referring to a standard which was withdrawn by BIS in 2001. In 2010, you're referring to standards withdrawn in 2002 and 2006. In 2010, you are having a gamut of standards from 12065 to 14568, but not a single mention of 12615, which existed since 1989. इसका मतलब क्या है? साफ है, ये कंसल्टेंट स्पेसिफिकेशन जब पहले 1960s में बना था, उसके बाद ये क्लॉज को किसी ने हाथ ही नहीं लगाया है। Coming back to sir, whatever sir said, learn to challenge the status quo. जब भी ऐसी बात आती है, there are many people who understand, this whatever this fellow said makes sense. The moment this matter is taken to the seniors, आजकल का लौंडा हमसे ज्यादा समझता है क्या? And I'm sorry, this is what actually happens. This is unfortunately in India. But try to understand. We are not challenging your wisdom. Don't let them feel that we are challenging your wisdom. मैं ऐसा नहीं बोल रहा हूं कि पहले के लोगों की अक्ल ठिकाने पे नहीं थी। ये तो हमारी अक्ल ठिकाने पे नहीं है कि उनके जमाने में जो सही था वो आज की हालत में भी सही मानते आ रहे हैं। एक ही एग्जाम्पल दूंगा, दादाजी के मुंह से सुना होगा दिया तले अंधेरा। जब ट्यूबलाइट ऊपर से लटकती है, दिया के ऊपर अंधेरा होता है, नीचे नहीं। Continue following diya tale andhera, you are making the mistake, not your dadaji made a mistake. And this is what I need to change. Starting current 6 times, EIL ने लिखा था 1960s में, जब अपना power grid was a pathetic affair. EIL themselves do not talk about restricting starting currents anymore. But the rest of the control C, control V consultants still follow 6 times restriction. And जैसे बताया, कंसल्टेंट की बदौलत हम मोटर मैन्युफैक्चरर का सेल काफी गुना बढ़ता है। नुकसान किसका है? आपका। आई एम नॉट गेटिंग इनटू रीडिंग आउट ऑल दीज थिंग्स। कंसल्टेंट स्पेसिफिकेशन शुड एंश्योर ट्रबल फ्री ऑपरेशन, एग्रीड, but not at the cost of oversizing and resulting inefficiencies. And this is where I said, you are responsible for energy efficiency. कंसल्टेंट का फंडा क्लियर है, जितना प्रोजेक्ट कॉस्ट ज्यादा उतना उसका कमीशन ज्यादा, और जब 45 किलोवाट के लिए 160 किलोवाट की मोटर दी जाएगी, मोटर फेल होने का तो चांस है नहीं, आप कोई भी जात का उस पर पेनल्टी लगाने वाले हो नहीं, लेकिन एफिशिएंसी बिकॉज तेल लेनी गई है, उसका कंटिन्यूअस रनिंग एक्सपेंडिचर जो बढ़ा हुआ है वो उठा रहे हैं आप, न तो मोटर मैन्युफैक्चरर न तो कंसल्टेंट। नाउ I'll take a little pause if I can get some water to drink. Thinking out of the box is not a trainer's jargon. Let us give you some serious food for thought. If you think out of the box, you will get an unprecedented energy savings. And this specifically, this entire slide set now, अभी तक जो था वो generically मैं सब जगह पे बात करता हूँ, but this is specifically intended for the esteemed gathering of paper plant guys over here. I'm introducing an idea which is known as pole optimized motor selection. What does this idea call for? An induction motor, when operates with a VFD, operates into 3 zones. Flux constant zone from 0 to the rated frequency. After that, into field weakening zone, which is further divided into slight field weakening or deep field weakening. I'm not getting into all this explanation of this curve right now. I'm just trying to bring to your notice where you can utilize this. Let us understand pole optimized motor selection. So if the driven machine has such a characteristics, on the left, constant torque over a certain speed range, after that constant power. Yeah, constant torque over entire speed range. Both these kind of machines exist in a paper plant. Then in that case, pole optimized motor selection is possible. So what is pole optimized motor selection? Instead of selecting a 4-pole motor, which will continuously operate in the flux constant zone, if you select a 6-pole motor, which may operate slightly in the slight field weakening mode, then there is a possibility of resulting a smaller output and a significant reduction in converter current rating. How do we do that? 62 kg-meter of torque, 400 to 1100 RPM, constant required. After that, constant power till 1500 RPM. General observation is people want a 4-pole motor for this operation because the maximum speed of operation is 1500. So, 62 into 1500 by 974 gives you 95 kilowatts. So, the smallest possible theoretical rating for this requirement would be 95 kilowatt 4-pole. The next standard rating is 110 kilowatt 4-pole, which will fail over here. It fails over here because it does not overcome the required torque. And therefore, the next logical rating is 132 kilowatt 4-pole. लेकिन अगर मैं आपको कहूं कि be open, think out of the box, be open to run the motor in a field weakening zone, meaning 4-pole को मारो गोली, let us try a 6-pole motor. A 6-pole motor which will overcome this torque characteristics requirement of the driven machine is 75 kilowatt 6-pole. अब अगर आप कहते कि नहीं 132 किलोवाट के सामने 75 किलोवाट का मोटर मुझे कोई फायदा नहीं देगा, तो then I need to not discuss anything further. This is what is possible. I'll show you in terms of the current ratings. So from the drive current for the given load, 128 ampere for a motor rated current of 139 ampere if you use a 75 kilowatt 6-pole. And if you use a 132 kilowatt 4-pole, it is 228 ampere of motor rated current, 175 ampere of drive current. This 175 of ampere of drive current will be running through your cables. उतना higher I2R losses already आप build in कर चुके. Think about it. Think about the current rating of the drive. That is possible to be reduced if you are open to field weakening mode of operation. This was a case of constant torque and constant power. Let me take an example of a constant torque load. Simple constant torque load. 58 kgf meter from whatever speed range is indicated up to 1100 के आसपास, 1200 के आसपास है. From 500 to 1200. 110 kilowatt 4-pole motor works. So does a 75 kilowatt 6-pole motor. And for those who are in doubt whether the graphs have not been made with an purpose of optical illusions to cheat your sensibilities, no. The graphs are identical. They have been made for the same load on the same scale. There is no cheating over here. It's a fact of life. Be open to pole optimized motor selection, and you get to save tremendous energy not by addressing efficiency of a motor, but by reducing the motor requirement itself. Clear? Good. Now, I come to the last topic. And by that last topic, I seek an answer. How many of you know what a Jolly Roger is? No? Okay. In olden times, when on a sea voyage, dusk, heavy fog, and out of the mist, a ship appears. And when you put the telescope to your eye and look at the flag on the ship, this flag is known as Jolly Roger. So, seeing a Jolly Roger through a telescope means danger. I am now going to come to the last part of my presentation where I am going to tell you, forewarn you about the biggest threat, the biggest danger that you will encounter in your attempt to further energy conservation in your industry. Thank you very much. इसलिए बोल रहा हूँ कि पता नहीं my manager who is sitting here, will he let me be alive after I have delivered the rest of the slides, because it is going to affect him badly. But I'll still speak the truth. The greatest danger to furthering energy conservation lies from higher efficiency motors. And what do I mean by that? IE2 हमारा मिनिमम MBPS है, उससे हम IE3 जाएंगे, IE3 से हम IE4 जाएंगे, उसके बाद हम IE5 जाएंगे. देख लीजिए IE2, IE3, IE4 कंक्रीट था, लेकिन IE5 में 5 अभी भी हॉलो है. ये हॉलो इसलिए है, the IEC says motor technologies for IE5 are currently not well developed. It also says IE5 is envisaged. There doesn't exist any standard which talks about IE5. There will be many people who will come and tell you, हम IE5 देते हैं. As per which standard? The standard doesn't say anything about IE5. Forget that. उसके बाद क्या? और उसके बाद क्या is a very important question. Why? Now I am going to tell you, spill the beans in a different way by taking an example of a 30 kilowatt centrifugal pump whose efficiency is 55%. With the input required will be 54.55. With a 15% margin, there's a standard which says absorb power के ऊपर इतना margin रखना है. The next motor rating is 62.73 kilowatt. Therefore, the next standard rating is 75 kilowatt. A 75 kilowatt two-pole motor running at 2976 RPM will have an annual power consumption of 502.57 megawatts when operating at a load point of 54.5 kilowatt. अब मैंने 502.57 मेगावाट क्यों दिखाया आपको? इसलिए नहीं कि वो कैलकुलेशन से आता है. आई वॉन्ट टू ड्रॉ योर अटेंशन टू समथिंग एल्स. अभी तक मैंने बहुत बड़ी बड़ी फिगर्स दिखाई दी आपको. 7.3 मेगावाट आवर, 14.4 मेगावाट आवर्स एंड ऑल दैट स्टफ. 502.57 मेगावाट आवर की कंपैरिजन में इफ आई यूज एन i3 मोटर आई सेव ओनली 2.31 megawatt hours. If I use an i4 instead of an i3, I save only 2.75 megawatt hours. If I use an IE4 instead of IE2, I get to save only 5.06 megawatt hours. I'm not demeaning 5.06 megawatt hour ka importance. I'm bringing to your notice this 5.06 megawatt hours is a negligible percentage of 502.57 megawatt hours. However, if I replace the pump with the one which has 10% higher efficiency point, just 10% higher efficiency, then your motor rating reduces to 55 kilowatt, and the annual savings that you accrue from this is 75 megawatt hours, which is definitely not negligible as compared to 502.57. What do I mean by that? higher and higher efficiency improvements or energy conservation results will now only be possible once you start looking away from motors and looking at the driven mechanical equipment, which unfortunately has been ignored because of the fault of two people. One, us, the motor industry. हम लोग हायर एंड हायर एफिशिएंसी क्लास देते आ रहे हैं तो आपको वो आसान लगता है. दूसरा, इलेक्ट्रिकल पावर इनपुट मोटर वॉट मीटर के सामने खड़े रहो तो सीधा सीधा दिखता है, लेकिन मैकेनिकल इनपुट पावर टू पंप दिखता नहीं ना. जो दिखता नहीं उसके बारे में फिक्र करता नहीं कोई. What does the standard say? Further efficiency optimizations will have to focus on system efficiency. Motors काफी हो चुका. मैं ये नहीं कहता कि आप i4 मत लीजिए, मैं ये नहीं कहता कि i5 मत लीजिए, पर if you are really serious about energy conservation efforts, look at the driven machine. So this is my penultimate slide. My last slide will be not this, of course there is one more. So for further and significantly greater reduction in energy use and carbon footprint, start looking beyond the motor. So summarizing, it is the energy saving that matters and not the efficiency difference. So delta kilowatt hours is more important than delta efficiency. A properly sized motor is more efficient than one operating at service factor. So SF 1.0 is better than SF 1.x with x greater than 1 or x greater than 0 for that matter. Insisting for CE marked motors always works to your advantage. So CE is better than non-CE. Blind replacement of existing motors with EEMs can be counterproductive. I have already given you a thought for that. Check if your consultant specification is resulting in criminal oversizing. 45 किलोवाट के सामने 160 किलोवाट, इसको criminal oversizing ही कहा जाता है. Sometimes operating a motor in the field weakening range can be beneficial. And the last point, further energy conservation efforts should concentrate on driven machine efficiency improvement. I hope I have given you enough to seriously think about, and I hope, Goelji, I have been able to meet your time criteria. Thank you very much. Sure.